So I'm going to start with just this chart that I will ask you to reference a lot. I'll try to give you some good ways of memorizing it and understanding it. And you'll have to tell me when we're done going over this if this is brand new to you or if you've done it before but just need more work on it. So transformations first and foremost. That's your translation. So your shifts, you can move things left, you can shift things right, up, down. Are we all okay with the fact that vertical means up and down movement? Over the years, I have realized that not everybody knows that, as if it's second nature like I would have thought. So I want to make that clear. Vertical is movement up and down. So for a shift, and those are the first two, that's just literally moving a graph 3 units up or 7 units down. And then horizontal movement is left, right. So shifting again to the left or to the right. A dilation, if it's vertical, a dilation is going to stretch a graph really away from which axis? If you think about a graph, if I stretch something vertically, which axis is it stretching away from? The x-axis, very good. Or a dilation also could be a compression. So I could kind of sort of smush it and everything would get smushed towards the x-axis, okay? And then if it's a horizontal one, obviously it's pulling left and right. It's pulling and stretching away from the y-axis. If it's a stretch or a compression, would kind of shift and smush everything towards the y-axis. So we kind of make it more narrow. Does that make sense? Those are your dilations. And then a reflection, we all know, is just kind of a flip. So we'll either be flipping vertically. If you flip something vertically, which axis is it flipping over? The x-axis again. And if it's a horizontal reflection, it's flipping horizontally left-right over the y-axis. Okie doke? So as far as your operations go, shifting will always be accompanied by an addition sign or a subtraction sign. Okay? And believe it or not, well, we'll get to it in a second. A dilation is always indicated by when you take a function and you multiply it by a number. Okay? If you multiply it by 3, for example, believe it or not, that could actually be a stretch of 3 if you multiply by 3, or it could be compression by 3 if you multiply by 3. Those are kind of the differences between vertical and horizontal that we'll get into. And then a reflection is always if something just gets negated. If you throw a negative sign in front of something, it reflects it. So let's do vertical first. And maybe we'll even compare the columns. What do you notice in your vertical column? F of x is your function in both cases. What do you notice about the operations happening to f of x here and the way it's written versus the way things are happening to f of x in the horizontal column? Elena?
For f of x, for vertical, the operation's always on the outside.
Very good. Outside. So the f of x is kind of untouched. That little set of parentheses just is still just containing x, and everything that happens is on the outside. That's how you know it's vertical movement. So an f of x with a plus 3 at the end or on the outside would shift the graph up 3. If it's f of x minus 3, it's going to shift it down. If it's 3 times f of x, that's a multiplier, so that's a stretch by a factor of 3. And these are all in the vertical column already, so I'm not putting necessarily vertical shift up, vertical shift down, vertical stretch by 3. But when it's kind of an open response, you would always start with horizontal or vertical. This one is multiplying by 1/3. Now, when you multiply by 1/3, you're actually shrinking that y coordinate. So this is a vertical compression by 3. And a negative is a vertical reflection. Now the horizontal column, as Elena kind of said, you'll notice all of those numerical things are happening within the set of parentheses. Okay? Here's the doozy about the horizontal. Everything is going to be the opposite of what your gut instinct would be. For example, if you think about left and right movement, if you were adding 3, wouldn't you think that would move it to the right? And it doesn't. Because everything horizontal is the opposite of what you would think. So just remember that. So you would think that would be the right 3. That's actually a shift left. And on the next one, -3 you would think would be to the left, but in reality it's to the right. You would think multiplying by 3 would stretch it out, but it actually compresses it horizontally. So here you do have to put horizontal compress. Obviously, if you're using terms like left and right, saying horizontal is a little bit redundant, right? Left and right kind of already means that. But with a compression, you definitely have to say horizontal or vertical. And then likewise, when you're multiplying by 1/3, you would think multiplying by a fraction like that would compress it, but it's horizontal, so it actually stretches it. Do you notice with those fractional multipliers that I'm still saying I'm using the reciprocal to say what it's stretched and compressed by? So keep that in mind. And then on the last one here, this is just a horizontal reflection. There's no really, on the reflection, it's not really the opposite of what you would think because there's no direction attached to it. Now, if 1 is brand new to you and 5 is you know this very well, give me on a scale of 1 to 5 where you are with this. Go. Okay, so a couple brand news, but you're somewhere in the middle, a lot of you. So that means you've done it before, but maybe not at the level that we're about to. Okay. So what I have at the bottom here, and I don't know that we're going to do every single one of these. The graphs aren't showing up great on that thing, but I think you can see them decently well on your paper. I'm just going to kind of draw this in a little bit more definitively. What I will say on any function, if you're about to start shifting it and moving it and so forth, you want to pay attention to the critical points. Okay? There are an infinite number of points on this graph. You really want the critical one. So it looks like there's one right there at -3, 2. The y-intercept is always a pretty critical point. So that's at 0, -1. Then it comes to a point at 1, -2. I'd call that a critical point. Any turn or intercept is a critical point. The x-intercept would be a critical point, but it's not really an exact x-intercept. It's somewhere between 1 and 2, so I'll stay away from that. But there is a critical point at 2, 1, and there's also a critical point, this one's harder to see, at 3, 1. So it kind of has a little flat plateau at the end. So just to make that darker for you guys. Now, g of x plus 3. Jack B, what's the transformation? Very good. Vertically up 3. Vertical because it's outside the g of x. Plus, that tells you it's a shift, and then gives you the direction of up 3. So you'll take your, 1, 2, 3, 4, 5 critical points, move them all up 3, and just reconnect. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And if you're dealing with just a shift, your new function should run parallel to your other function. Okay, it is the same graph for all of these. So if you want, you can just highlight the critical points again. Exercise 2, Owen, is what kind of transformation? Horizontal left 3. Very good. So we're just going to take our critical points. And move each and every one of them. This one's a little bit trickier to see that parallel concept because they overlap. But each individual segment is parallel to its image. So that this one, and here's its image. This one, and here's its image, and then the other two. So this exercise 3, we're not going to do it, but it would be a down 3. And exercise 4, Lucas B, would be what? If you had to describe it. Right 3, very good. Nice job, guys. Pretty good for day 1. Okay. Now, stretching and compressing can get a little bit tougher because everything is going to move a different amount. So I'm going to darken my critical points again. Now, exercise 5, Sierra with an S, is what? Start with horizontal or vertical.
Vertical.
Yep. Vertical, stretch by 2. So every point isn't going to move the same number of units anymore. Okay? What's happening is we're vertically stretching away from the x-axis. So if you start with the first critical point, it is currently 2 units above the x-axis. If we're doubling that, that 2 units is going to become 4 units. If I look at my x-intercept, my next critical point, that's 0 units away from the x-axis. When you double 0, what is that? Still 0. So that's actually going to stay right on the x-axis. The next critical point is currently 2 units below the x-axis. Double that, it's now going to be 4 units below the x-axis. The next critical point is 1 unit above. Doubling 1 now puts it 2 units above. And the last point over here, 1 unit above, again doubling that puts it 2 units above. So again here, it's somewhat tough to see because these overlap each other. But we just really have elongated this picture. We've stretched it vertically. It hasn't gotten any wider. It still ranges, or it has a domain of -3 to 3. But we have stretched it, so the range now starts lower and ends higher. It's become longer and skinnier, taller. Okie doke? Exercise 6. Sierra with C. Describe that for me. What is it? Horizontal what? Very good. Horizontal compress by 2. Or by a half, really. Does that make sense to everybody? So if you're compressing it horizontally, it's going to whatever distance it currently is away from the y-axis, we're going to half that and smush it inwards. Yes? So this particular one right now is 3 units away from the y-axis. If we're taking half of that, what's half of 3? 1.5. So this is going to get tricky because you kind of got to place it perfectly halfway there. Your x-intercept is 1 unit away from the y-axis as is. If you take half of that, that's going to move only a half a unit away. If you look at your next critical point down here, at that point, it's 1 unit to the right. Take half of that, and it's only now a half a unit to the right. Oh, did I skip my y-intercept? I did. My y-intercept was right on the y-axis. So if you compress it towards the y-axis that it's already on, it's still going to be in that same fixed spot. And then this next point is 2 units away. It's going to become 1 unit away. And the last one is 3 units away. It's going to become 1.5. So those two are really close to each other. But you still connect it. You get the same general shape. But we've horizontally smushed it. So the domain shrunk a little bit, right? It was from -3 to 3. Now it's from -1.5 to 1.5. And the range stayed the same. If we didn't stretch or do anything vertically, the range is still what it was. Are we good with that? Okay. Exercise 7, just tell me what the transformation would be. We won't draw this one out. Jason. When you say dilation, you have to be more specific. Stretch or compression?
Oh, compression.
Compression, very good. Very good. Number 8, Eric.
Stretch.
Horizontal or vertical? Horizontal. Stretch is correct. We would actually just say by 2, right? That makes sense to you? Sometimes you reciprocate that because a stretch really should be a whole number and a compression really should be a fraction. Good? And then 9 and 10 give us our reflection. So this negative sign being outside the function is a vertical reflection over the x-axis. And 10 is a horizontal reflection over the y-axis. I'll do the vertical reflection. So again, it's all about how far away is it from the x-axis. So this first critical point is 2 units above, so that's going to flip to 2 units below. Anything that's right on the line of reflection is going to stay put. This next critical point is 2 below, so I'm going to flip it to 2 above. This next critical point is 1 above, it's going 1 below. And the last critical point is also 1 above, I'm putting it 1 below. So when you draw the reflection on the original, it should create something that is symmetrical to the x-axis, right? Because the x-axis was that line of reflection. Okay? So in 11 and 12, the only thing we have really left to talk about just on this introductory day is what happens when you need to do more than one transformation at a time. We have to talk order of transformations because the order does matter. Okay? There are definitely examples out there where whatever order you do it in, it wouldn't really matter, but for the majority of the time, order matters, and if you do your transformations in a different order, you'll end up with a different picture. So, being that it's math and there's one right answer and one right answer only, there has to be a certain order we have to follow. Here's the first rule of thumb. Anything horizontal happens first. So, in this particular number 11, we have maybe 4 transformations. We've got a 2 on the outside, a negative on the outside, a +1 on the outside. That's all vertical stuff because it's on the outside. On the inside, we have this -7. That's a horizontal. All things horizontal happen first. So let's address this first. The first transformation is a horizontal what? What does that say? Yep, horizontal, shift, right, 7. And again, in that particular case, you don't necessarily need horizontal because the word right covers that. But it's just a habit I get into is starting everything with horizontal or vertical. So that's next. After that, you go through your order of operations. What would you do next if you were just following PEMDAS? Lucas?
Multiply the -2.
Multiply by the -2. Now, yes, in PEMDAS we would multiply by -2 all at once. Speaking of transformations, that's technically 2 steps. And whether you handle the negative first or the 2 first, that really doesn't matter. So the negative we'll do first is a vertical reflection. The 2 is a vertical stretch by 2. And I ran out of room. And then the last thing in your order of operations is +1. So that would be a vertical shift up 1. So in that order, just these middle 2, because it's the same coefficient of -2, that can be in the other order. Okay? On this last one here, we have, I'm sorry, I know it's blurry. I would hit the focus button, but sometimes my video stops recording, and it's really, then I'd have to do 2 videos, but I'm just going to suffer through it because I know you have it in front of you. So what transformation would you list first, Tess? Yep, by? Well, it's a stretch, so the number should be greater than 1. So a 1/5, what's the reciprocal of 1/5? Well, we're just going to go with the 5. The negative is technically a different transformation, right? When you negate something, that's a horizontal reflection. So that covers the negative and the 1/5. What would come next, Corey?
Vertical compression.
Very good. By?
1/5.
Very good. See how compressions always are paired with a number less than 1. And then last but not least, oh boy, whose voice haven't I heard? Haley.
Vertical down.
Shift, we'll say, yep, down 2. Very good. Awesome. So, I'll pass out your homework, but I also, while we're